In this video, we are going to look at something that might be new to some of you. That is, we're going to take a look at logarithmic functions. Logarithmic functions are kin to exponentials, and we're going to discover just how that is. As always, let's define it before we talk about it. First, if x is positive and b is positive, with b not being 1, then the logarithmic function log base b of x is equivalent to b to the y equals x. This base to the y power equals x. This is my exponential function. This is my logarithmic function. Okay, we call f of x equals log base b of x the logarithmic function with base b. A good deal of practice here will go a long way, so let's do a few of them. First, rewrite it in exponential form. So 2 equals log base b of x. I'm going to change that into b to the second power equals x. On part B, my base to the third power equals 64. On C, again, my base is 3. What it equals is my exponent, and then that equals what's left. Okay, so it's really not that hard to write it in its exponential form, and that's going to be a key for some of us in how to solve. Now let's take a look at going the other way, changing from exponential form into logarithmic form. My base here is 12, so log base 12 of, who's on the other side, x, equals my exponent. Log base b of the other side equals my exponent. Finally, in this last one, now this is kind of weird. This is somebody important, so it's weird for me to write it this way. But log base e of 9 is y. Euler's number here, we're going to have a special name for his inverse, and we'll define that in just a second. But before we do, let's take a look at evaluating logarithms. Now, the way I like to do this is to consider it equals x, and then change it into exponential form. 2 to the x equals 16. So I say 2 to the x equals 2 to the fourth. I write 16 as 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. Then because I have the same base, x must be 4. So to evaluate that, that value is 4. Let's try it again. Log base 7, okay, equals x if you want. So that's to the x power equals 1 over 49. Well, I cannot write 7 as 49 to some power. Actually, I could. I just don't want to. So I want to write 49, though, as 7 squared. But one of my 7's is in the numerator, the other 7 in the denominator. But I know how to move it from the denominator to the numerator. I change its exponent to negative. Then I have a common base, so my exponents will yield the answer x is negative 2. So that value would be negative 2. Okay? All right, let's look at C. 25 to the x power equals 5. I'm going to write 25 as 5 squared to the x power equals 5. That is 5 to the 2x equals 5 to the first. So 2x equals 1. X equals 1/2. Remember, the 1/2 power is the square root, so that does work. Okay, and D, 2 to the x equals 2 to the 1/5. I already have a common base, so x is 1/5. I have to remember the radicals are the reciprocal powers.